Boom. 50. What volume of CO2? Wait, before we even complete this question, this is question number 50, and that means we are halfway done through 100 questions on stoichiometry. By the way, after stoichiometry, let me know what topics we should treat next, okay? So this here has to do with volume and concentration and number of moles, okay? What volume of CO2 is produced at STP when 500 ml of 0.1 molar Na2CO3 is reacted with excess HCl? HCl is the excess reagent there. We're using our limiting reagent for calculation, but first, we need an equation of reaction. So Na2CO3 plus HCl. This would give us the Na here has to pick up this guy and form NaCl for us. That's the first thing. The H also has to pick up some oxygen from there, giving us some water. And then because that's a carbonate 4, it's going to let out CO2 gas. Our equation is ready, but is it balanced? Maybe it's not balanced. We have to check. This is Na2, so put a 2 here to balance the Na. Then the 2 you've put here now has created a problem. Has made our Cl2, so we have to place a 2 in front of the HCl as well. So that should help us salvage the situation. Is it looking nice? Yeah, it is. Every other thing is balanced. So this is our equation. What do we need to use it to do? We will probably need it to compare stuff, right? What is the volume of CO2 produced at STP when 500 ml of this amount of this is reacted with excess HCl? So we are comparing Na2CO3 and the CO2. That's what we're comparing. Because the excess HCl is in excess, so we don't really care about it, okay? What is the number of moles of Na2CO3 we have? Number of moles equals concentration times volume. So that's 0.1 molar, which is mole per dm cube or mole per liter, times the volume, which is 500 ml. This 500 milliliters is actually 500 divided by 1,000 liters, okay? So that the liter can cancel out here. What's our number of moles? That should be 0.05 moles. Okay, so 1 mole of Na2CO3 produces 1 mole of CO2. We can see that because this is 1 mole here and this is 1 mole here. So you see why this equation needs to be balanced in the first place, because that would influence the relationship. Okay? So if 1 mole of Na2CO3 gives us 1 mole of CO2, that just tells us that 0.05 moles of this guy will produce 0.05 moles of CO2. So the number of moles of CO2 produced is going to be 0.05 moles. The question asks us to get the volume of CO2 produced at STP, not number of moles. But we already know, do we know this, that 1 mole of a gas like CO2 at STP occupies 22.4 liters. Do we know that? That would come in handy here. So if we want to get the volume produced, we know that 0.05 mole was produced. Then that means our amount in volume would be 0.05 times 22.4. And what would that give us? 1.12 liters. And that is the answer. If you're seeing this video for the first time, if you've not seen me before, hello, I'm here, I'm helping people with chemistry, and it's nice to meet you. Subscribe if you're seeing this on YouTube so that you'll see question 51, okay? And if this is your first time, put it in the comment section first time so that I'll be able to say hi to you over there. And I'll see you on 51, okay? Take care and bye-bye.